definition of composites, then I will go to the metallic composites and to the functionally graded materials. So the concept of composite is really good to the engineering materials, and mostly the composite materials are man-made materials. Apart from the two major things are the wood and the bone, which is natural composite materials. So by definition, a composite is a mixture of two or more materials with distinct interface prepared in an engineered way. For example, the bulk phase is the matrix and the reinforcement is the filler. That means if you have a polymer, then it is which acts as a binding phase, then it is called the matrix, and the filler which is used of the reinforcement. And the property of the composite is the sum of the property of the matrix and the reinforcement, and in most of the cases it is the synergetic effect. That means it combines because it uses properties of the fiber. That's fibers use the most of the strength to the composites, and this matrix acts as a binder for the fibers, as well as it will be transferring the load which is applied to the component to the fiber, and the fiber takes the maximum load when it is applied for a component. So the composites typically consist of strong, stiff, and tough resins, which is reinforced in the resin. And as I was mentioning, that wood and bone are the natural composites. You take wood, so what is wood means? Wood is of cellulose fibers reinforced in a lignin matrix. That is, the lignin is the binding material in a wood, and the fibers are mostly cellulose fibers. So that is why the stick, stem, and tree, which has a very high strength because of the presence of the cellulose fibers. So man has started imitating this natural material, just like wood and bone, to synthesize various type of engineering materials. And bone is another material, that is the which contains hydroxyapatite particles in a collagen matrix. That means you can see that the very fine calcium, aluminum, phosphate materials, that is hydroxyapatite particles, are dispersed in collagen matrix to make this type of composite materials. And this is an example. For example, you can see this is a bone which contains denser outer structure and porous. So this is a typical example of a functionally graded material also. Because normally, if it's a homogeneously distributed, then we can call as a homogeneous composite. And if it is a graded type of this type of material, it is called a. And similarly, you take this cut cross section of a bamboo tree. So you know that bamboo tree, which is hollow inside, and this outside shell will have a very hard fibers. And this hard fibers takes the total load of the tree. Actually, any tree you take that outer shell which is having, and some trees have the inner core is also, that depends on the type of trees. And here in the case of bamboo trees, it has a very hard shell, and this takes the total, if a wind flow is there or anything also. So only we use this bamboo and wood for various structural applications, or even the construction from old days to and the inner core is a very sharp tissue, and this tissue is used mainly for transporting the minerals, water, and other materials which is developed, which is required from the growth of the tree. So you have the water which is taken from. So inner has a function of for the growth of the tree, and outer acts as a structural material. So this is a type of functionally graded material. That means in a same structure itself you have two different functions. So the outer function is to as a load-bearing material, or the material which can withstand any type of load. The inner is a functional role of transporting the liquid and mineral from the root to the top. Again, you take the bone. So the bone has two different functions. Why the outside bone is very stiff means it has to take the load. Your body has to withstand means this has to take. So this is a denser size, and inner shells has because you have to this bones has to be keep on regenerating. So what you have to do is that this has to absorb the calcium, and there will be some type of calcium deposition from the outside also. So this bone will keep on regenerating. Apart from that, this bone also has porous structures which will act as some type of catalytic structures from where the RBC, the red blood cells, and WBC, and many of the body fluids are getting generated. That is why the backbone is very much important for the development of various types of body fluids and so on. So it has dual function. The outside shell has a function of load bearing, and the inner shell has the function of generating the body fluids as well as the transportation of body fluids and to regenerate the bones, because you don't have the same calcium throughout when once you bought, because it has to keep on growing as well as it has to keep on regenerating. So this is a multi-function role which so we can have these type of materials as a functionally graded. It's also a composite as well as a functionally graded material which is occurring in the nature. Even you take the whole body structure. So if you see, imagine that you remove all the bones. So we just lie flat, and all these bones act as the reinforcement. That even we can tell that body itself is a ceramic reinforced organic composite. That means organic means the organic material. That means the skin, the body fluids, everything is made of different types of organic materials, and the whole bone itself is a ceramic material. So we can. So unless you have a basic structure, then even you take a finger, unless the bones are reinforced in your finger, you cannot apply load, you cannot use it. So the reinforcement in your body is the bone which you have inside, and this is used as a for the because any you put some pressure or pressure, immediately the load is taken by the bone because your tissues or the skin cannot take it. So the similarly the composites, the fiber is inside which takes the load, and that is the binder takes the load. Binder is just like your skin, and the fiber is just like the load bearing material which takes. Similarly, our bones take the whole load which is applied to the body. And similarly, the other engineering structures are, you can see the reinforced cement concrete. So what is inside the reinforced cement concrete? Steel fibers, steel rods. And all the steel rods take the load. Suppose you imagine that all the steel rods are removed from the structure. What happens? The structure cannot withstand. Even the buildings of many floors, 20 to 30, 40 and even 100 floors, it mainly stands because of the fiber which is there. Either it may be in the pillar or the roof. So pillar, because it has the steel reinforcement inside. So one of the main concept of civil engineering structures is the composite materials. You have the binder, that is the cement, gravel, sand and other things, which is mixed and which is bind to keep your steel. Suppose you don't have the steel rod inside, means because the total structure will collapse, or the rod of sufficient strength is not being reinforced, then can totally the structure it cannot take. So the real strength or the real backbone of the civil engineering structures are the steel which is reinforced inside the cement complex. So that is one of the best another example of composite materials is the reinforced cement. That is RCC materials or the RCC roof and other things. So we always see